So this is a video, a real quick video to show how we could use regression with an indicator variable to also do a two-sample t-test and show how we've got similarities and possible differences between the two approaches. So before, when we did the memorizing letters example, we used a two-sample t-test to analyze results of the memorizing letters experiment, where we had a purple list and a blue list, and the purple list was familiar groupings of letters and the blue list was unfamiliar groupings of letters. In that experiment, we had the mean results for the purple list of 19.53 letters memorized, and the mean results for the blue list was 12.49 letters memorized on average for that sample. We could instead use a regression model using indicator variable where x1 or x equals 1 for the purple list for familiar groups and x equals 0 otherwise. We could also write that as x equals 1 for purple or 0 otherwise. So that would be the definition of our indicator variable. Thus, our population model would be mu equals alpha plus beta x, where x is our indicator variable. So if we have the purple, or unfamiliar groupings, or familiar groupings, our population model will be mu equals alpha plus beta times 1. So that would just be alpha plus beta. For the blue list, for the unfamiliar groupings, our population model will be mu equals alpha. And we can interpret these parameters much the same way as we did before. But we're going to jump right to the prediction equation because that's where we have values and it'll be a lot easier to interpret. In our prediction equation, we have y hats and sample statistics. So our prediction equation is going to be y hat equals a plus b x, where x is still our indicator variable and y hat is our sample response, our predicted response. For the purple list, x equals 1, and for the blue list, x equals 0. So we can plug in much the same way we did before. For the purple list, y hat is a plus b times 1, so that's just going to be a plus b. Now we have our prediction, our parameter estimates up here, so we can actually plug in those real values. So in this case, a is 12.49 and b is 7.04. So our y hat for the purple list is 19.53 letters. For the blue list, x equals 0, so we go the same route. So we have y hat equals a plus b times x equals 0. So this just becomes y hat equals a. We plug in, so this becomes 12.49 letters. Let's interpret these estimates in turn. A is the y-intercept. We interpret this the same way we always do. So this is the predicted response. So in this case, it's the predicted number of letters memorized when x equals 0. But in this case, when x equals 0, that means when people have the blue list. That is the unfamiliar grouping. So this is the predicted number of letters memorized when people have letters in unfamiliar groupings. Well, what did we see before? In this case, this is 12.49. So this is the predicted average number of letters memorized for the unfamiliar groupings, but in our two-sample t-test, we observed that on average, people are memorized 12.49 letters for that unfamiliar grouping or for the blue list. So that is consistent. So this is the same thing as y bar b, the sample mean for the blue list. So b in this case is 7.04. Well, this is a sample slope, but it's a slope for an indicator variable. So this is the predicted change in the mean response. So the mean response, so the mean number of letters memorized for the purple list versus the blue list. So on average, people with the purple list memorize 7.04 more letters than those with the blue list. And I can say it's purple list more than blue list because we define the purple list to be x1, the blue list to be x0. So when we go from 0 to 1, we see a positive increase in the average number of letters memorized because that slope is positive. So when we go for a 1 unit increase from blue to purple, we see a positive change in the average response. So what did we see in our samples? Well, when we went from the blue list to the purple list, on average, the change was an increase of 7.04, right? When we did y bar p minus y bar b, that difference was that same 7.04 letters. Let's do one last thing. We had y bar p was 19.53. Have we seen that number again today? We did. That's this y hat for the purple list. We said when x equals 1, y hat equals 19.53. So the predicted mean response when x equals 1 for the purple list is 19.53 letters. So y bar p is the same thing as y hat when x equals 1, because that's the predicted response for the purple list. So when we're using an indicator when we have a categorical explanatory variable and we convert to indicators and we treat it like regression, our y hats in regression are y bars for the 2-sample t-test. So if the only explanatory variable in our regression is a categorical explanatory variable, the y hats are the same thing as the y bars. We get the group means that we would have had by looking at our sample means. So we had y bar blue was 12.49. We had a y hat when x equals 0 of 12.49. Y bar purple for our 2-sample t-test is the same thing as y hat when x equals 1. So if you only have indicator variables in your regression model, then your predicted response y hat is the same thing as your sample means.